In this video, we're going to go over some basic routines that you'll use in several problems in this chapter. First, we're going to talk about how to convert grams to moles using molar mass. Let's say our first problem says that we have 86.7 grams of copper, and our goal is to convert this copper into moles. We would take our grams and divide them by the molar mass of copper. You can find this number on the periodic table. It's equal to the average atomic mass of the copper atoms. Please notice how I'm setting up the dimensional analysis to make it so that my grams of copper cancel in my calculations. This leaves me with moles, which is my goal. In this case, my answer will be 1.36 moles of copper after I round with the proper number of significant figures. Okay, let's say your problem starts with a certain number of moles. Let's say you have 25.4 moles of, I don't know, maybe magnesium chloride. If you want to convert this quantity to grams, first we need to make sure that we have our molar mass for magnesium chloride. I'll do that work over on the top. Let's see. We have one magnesium atom, and those weigh 24.30 grams per mole. And we have two chlorines, and those atoms weigh 35.45 grams per mole. So we'll just add those suckers together and arrive at a molar mass of 95.2 grams per mole. For these types of calculations, that's actually the most common place where people have errors. Now we know that for every mole of magnesium chloride, we'll have 95.2 grams of magnesium chloride. You may notice that I take the time to write the unit and the chemical in each part of the dimensional analysis. This is actually really helpful for checking your work later on to make sure that all of your units cancel. Okay, now the answer for this one is going to need some scientific notation. We have 2,418.08 grams per mole as our answer, but I only have 3 significant figures in the beginning, so I need to round. I'm going to write this as 2.42 times 10 to the 3, and then I'm going to make sure I have my units at the end, grams. Sometimes when we're doing calculations with moles, the question asks for an atom or a group of atoms inside of a compound. Let's say a question asks how many moles of oxygen there are in a certain number of grams of silicon dioxide. Let's say that's actually 2.34 grams of silicon dioxide. To solve this problem, we need to know the molar mass of the silicon dioxide, so I'll go ahead and write those values down. For silicon, we have 28.09 grams per mole, and for oxygen, there are 2 of them, and we have 16 grams per mole. So we'll have a molar mass of 60.09. Okay, back to our initial question. We start this off exactly like we did the previous problems. We'll use the molar mass, 60.09 grams of silicon dioxide. per mole. And now we can go to that original question, wanting to know how many moles of oxygen there are in silicon dioxide. Well, all we need to do here is a ratio. Inside of each silicon dioxide formula unit, we have 2 oxygens. So you could say every mole of silicon dioxide will have 2 moles of oxygen atoms inside of there. Now all we need to do is multiply across the top and divide by the bottom to arrive at our answer, which is 0.0779 moles of oxygen atoms. Similarly, you can use this question in another way, asking if you desire to have maybe 10.5 grams of aluminum, and you needed to refine aluminum from an ore, something like aluminum oxide, which has a chemical formula Al2O3. Okay, so if that's how many grams of aluminum you desire, let's first change these aluminum grams into moles using the molar mass. Aluminum's molar mass is 26.98 grams of aluminum per mole. And then, like our previous question, we can use a mole-to-mole ratio to change from grams of aluminum into moles of aluminum. I can see from my chemical formula that I have 2 moles of aluminum atoms for every 1 mole of my aluminum oxide. And since there is no such thing as a mole scale, I probably want to know how many grams of this ore I'm going to need. So I'll multiply my moles of aluminum times the molar mass to get rid of those moles. Aluminum oxide's molar mass happens to be 101.96 grams of aluminum oxide per mole. And now for this calculation, I would presumably multiply across the top and divide by each thing on the bottom to arrive at my answer, which is 19.8 grams of aluminum oxide necessary to refine 10.5 grams of aluminum. And that's how you handle questions where you need to change one type of moles to another type of moles when you're talking about elements within the same compound. Lastly, I think we should talk about how to change the grams of a particular substance into moles, and then from those moles into a type of particles. Whether those particles are atoms, ions, formula units, whatever. It's all really the same method. Let's say we wanted to know how many molecules are in 35.6 grams of sulfur tetrafluoride. Okay, I'll start to handle this like any mole calculation. I see grams, I need to change them into moles. Okay, so we'll calculate the molar mass of the sulfur tetrafluoride. With 1 sulfur and 4 fluorides, we end up getting 108.06 grams of sulfur tetrafluoride. Please notice I put my grams on the bottom part in my dimensional analysis. That is so I can cancel out those grams, get my units into moles. Okay, now my grams are canceled, I am in moles, and now I go back to that basic definition of what a mole is. 1 mole of any kind of particle is equal to Avogadro's number, 6.022 times 10 to the 23. Particles, in this case, the count of molecules of sulfur tetrafluoride. We multiply across the top and divide by the bottom to end up with a super huge number, 1.98 times 10 to the 23rd molecules. Pretty much, if the person writing your questions understands scale and proportion, you're always going to end up with a really, really large number with a large exponent for the numbers of molecules or atoms or formula units or whatever it's asking for. Now we should practice one, especially in your calculators, going from particles to grams. So let's start with, let's say, 4.56 times 10 to the 22 formula units. Of sodium chloride. We can treat formula units like we would atoms or molecules and cancel them using Avogadro's number. 6.022 times 10 to the 23. I'm going to abbreviate here. Sodium chloride formula units are 1 mole of sodium chloride. And from there, we can multiply the moles by the molar mass to get back to grams. Molar mass of sodium chloride is 58.44 grams sodium chloride per mole. And finish up this calculation. You should be getting a small number like 4.4. Let's see, you're going to have to round up that 2 on spot. Grams of sodium chloride. It's really important that you practice calculations in your calculator where you have exponents in the bottom portion of a fraction. Make sure that you use the proper buttons on your calculator. On most TI calculators, you want to look for a button that says EE when you're doing these calculations. On my calculator, I would type in 6.022, and then I usually hit a second button if you have a TI-84, or if you have a TI-89, there's just the EE button. And then you'll find the one that says EE over the appropriate button, and then you hit 23, and then that number is good to go. And your calculator will read that all as one phrase, and that's really important. If you don't have that on your calculator, you really need to put parentheses around this number so that you don't end up with a really, really large number that's really far from the answer. Make sure that you practice many mole calculations, as these are essential in almost every area of chemistry.